If I have something like, let's make this a little simpler. Square root of 5. That's the same thing as 5 to the 1/2 power. If I have the cubed root of 5, that's the same thing as 5 to the 1/3 power. If I have the fourth root of 5, that's the same thing as 5 to the 1/4 power. So all roots are fractional powers. So anytime you see a square root, it's like you raise the whole thing to a power of 1/2. So it's actually very similar to exponential, and all exponential rules work. And when I raise a power to a power like this, all I do is multiply these. So I get x to the 3 over 2. And that would be another way to simplify this appropriately. Now, for the sake of your homework, we're going to be going more this direction, but I wanted to talk about a whole bunch of different angles that we've taken on this, even in this class thus far. So, my first example is, what if I have something like root 27x cubed times root 27x cubed? Well, the beautiful thing about this situation is, if you have exactly the same thing in both of your roots, then when you multiply them, all you get is the stuff on the inside no longer in a root. And so that's pretty sweet. So yeah, that's that question. Next type of question I wanted to take a peek at. And sorry, this video was late. I wanted to make sure I looked at the homework assignment I was assigning you before I actually made the video, so that I could adequately prepare you. And that's why things are a little later today. I got locked out of ClassLink for like 24 hours, so oh well. So let's say we have something like root 24x cubed times root 16 x to the 5th. So this is a trickier type of question because we're stuck with multiplication of two square roots. The insides are not exactly the same, so I can't use the trick that I used on the previous problem to very easily just get to the final answer. So the way I can deal with this is actually to multiply these together. So 16 times 24 is 320 plus 64, 384. X cubed times x to the 5th is x to the 8th, and all that stuff is inside the square root. Cool, now that I've combined these, I'm going to need to factor 384 here. And so I'm going to cheat a little bit. I know 24 and 16 go into 384. The reason I know that is because I multiplied 24 and 16 to get that. And now these are way easier to factor, these pieces here. 16 factors to 4 and 4, which means that's a pair. So, and also the square root of 16 is just 4 by itself. And so I know I can pull a 4 out. If I factor 24, that goes to 4 and 6. The square root of 4 is 2, so I can also take a 2 out. You can also just get a pair of 2's by splitting it like that. 6 goes to 2 and 3, so nothing I can do there. Which means all that's left inside is I pulled out this entire term, I pulled out this entire term, and only the 6 is left inside. And so that 8 root 6 is the square root of 384. These two terms are the same. That is what I've established. And we could go into Desmos and show that these two are the same, or you can just take my word for it. Here, or understand the work or whatever. Anyways, if I'm splitting up x to the 8th here, I could do 8 different little things here and put x's on the end of these and circle every pair, boink, 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 and I'd get x to the 4th. Or I could do x to the 8th to the 1/2 and multiply 8 by 1/2 and get x to the 4th. Either way, I get x to the 4th. which means I get 8x to the fourth on the outside of the parenthesis and a square root of 6 on the inside of the parenthesis as my final answer. So this problem was heavily involved. There are a lot of steps when you have complicated messes like this. Let's look at another type of question. What do I want to do? Let's do the square root of 132 times x to the 7th. So this one, I didn't put multiplication in, so it's a little easier than the last one. What goes into 132? 11 and 12 go in. You're welcome to use a calculator on any of these. You don't need to be able to do these in your head. Okay, so root 11 times root 12. Either of these perfect squares? The answer is nope. So I gotta keep going. So I get 4 and 3. Are either of these perfect squares? Heck yes, root 4 is definitely a perfect square. So I know that splits to 2 and 2. Anytime I can circle a pair, I can pull it out. So I'm allowed to pull out a 2. Now, what's left on the inside? This 11, stuck. 11's a prime number. Nothing I can do with it. This 3, also stuck. 3 times 11 is 33. So all that stuff is left inside. Now, the x to the 7th. 1, 2, 3, 4, 5, 6, 7. You could do 7 little x dudes here. And circle pairs, which means I'm allowed to pull out 3 x's. So I should get an x to the 3rd. And there's one x left over that had no friends, so it's stuck inside the square root. Now, what I do to simplify my final answer is multiply the stuff that isn't in the square root, 2x cubed. Multiply the stuff that is in the square root, so root 33x. And now we're totally done. That was the play. And our last type of question is, what if there's more than one variable in your question? Does this throw us completely off? So let's say we have something like 28 x to the 11th, y to the 6th, z squared. All right, so first steps first. Let's deal with the 28. So what multiplies to 28? 4 and 7 multiply to 28. 4 splits to 2 and 2, or you could just say square root of 4 is 2. Either way, you get to pull out a 2, and you get a 2 root 7 for the root 28 part. But then I got to deal with the x, the y, and the z. So I could do 11 little lines here. But, I mean, the moral of the story is, if you take x to the 11th and multiply by a half, you get x to the 5.5. Which is the same thing as x... Oh, I just realized I went off the page. Sad Mr. Kennedy. Why did I do this? So anyways, x goes to x to the 11th times 1/2, which is x to the 5.5. X to the 5.5 is x to the 5th times the square root of x. This is the same thing we would have gotten if I had written out 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11 x's, and then circled pairs. 1, 2, 3, 4, 5. 5 x's on the outside, 1 x left on the inside. So either way, that's what I get for my x's. So this is my number answer, my x's answer. The y and z answers are going to be way easier. If I understand the half power thing, y to the 6 just goes to y to the 3rd on the outside. And z squared goes to z on the outside. So what do I have on the outside? I have a 2 from the 28. I have an x to the 5th. I have a y cubed. I have a z. And what's left inside the prison of the square root? A 7 from here, and an x from there. So the nice thing is, anytime you have an even power in a square root, that entire thing's going to come out at just half of the exponent that it was inside the square root. And then if it's odd, you're going to be left with one of the dudes still stuck inside the square root. Now, just a real quick prepare you for the future type thing. So that was our final answer, was this mess for that one. What if we take a fifth root of something like 2x to the 7th, y to the 10th? Turns out this isn't a ton harder than before. When you take a fifth root, you need 5 of something. So if I wrote all the y's out, blah, 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 blah. Y 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. I know I don't have enough lines. There we go. I'd have to circle 5s at a time to pull them out. Or I could just multiply 10 by 1/5. And I get a y squared on the outside. How many x to the 5ths can I pull out of x to the 7th? Only once. I'm going to pull out an x to the 5th, and I'm going to have 2 other x's stuck inside. And so I can pull out an x. The 5th root of 2 is some horrible janky decimal, so that's stuck in prison. And it's stuck with the 2 x's I couldn't pull out. And this is all we'd have to do for the 5th root to simplify this. Now, this is definitely something we're going to be covering in the future, actually towards the end of this year. I just wanted to give you an intro because I think it helps for understanding how to do a lot of the trickier ones just inside square root. So remember, for square root, it's always just a second root. So for all the problems on this assignment, it's always going to be to the 1/2.